Organization. Objective that India is looking to, and the problems faced by in urbanization and the people living in urban areas are very live and very important problems. We want to address all these issues. The vertical urbanization and all that is so important, and it's not only Mumbai, but there are other cities in the country that are growing in similar fashion, and it's going to be a main focus of all studies henceforth. So we want to actually create awareness in all the planners, designers. Not only that, even the people who want to live in tall buildings, they should be aware how to live in tall buildings. That is our focus. Uh, so CTBUH itself, as a global organization, conducts annual conferences, country-wise conferences, regional conferences, seminars, even breakfast meetings and dinner meetings, networking sessions to bring people together and share knowledge and information. All that is going on. CTBUH India is following the steps. With all such activities, as I told you, our senior core group it consists of very senior people, and they devote their time to plan and strategize our activities. This is the active executive committee, and then we keep on inducting new core members to expand our activities. We have patrons who support us financially as well as with their own resources, and all such interested people, they contribute their knowledge, resources, everything to information about tall building, every aspect of tall building. Now you can go through, since we started in 2015, you can go through this plethora of activities that we have conducted. So many seminars on every aspect of tall building. Tall building is really a multidisciplinary field, right from architecture, facade, elevators, fire, plumbing. Now plumbing is very important aspect, and then traffic, and then even wind actions and earthquakes and everything. So every year we have been doing at least 4 to 5 sessions on a variety of aspects. We also go to colleges, as I told you, and try to induct new people into our, in fact we have, as you go ahead, you will see a Yuva front of CTBUH, very enthusiastic people. So traffic, car parking, we are now lately we have been touching on health and environment and sustainability. That has been our main focus nowadays. Last conference was in Chicago, and every world conference is held in a different major city in the world to engage the people there. We also collaborate with other organizations, like-minded organizations like ISCC and then FSAI for fire. This is the this is the CTBUH walk, and we every year we hold this walk through with a theme, and there is always an enthusiastic response. And I must tell that India holds the record for maximum participation among all the CTBUH chapters across the world. And then as I said, we also collaborate with other organizations. ISHRE, we have done 3 or 4. Last year we entered into collaboration with them. So since then we have done about 4 events in different cities: Hyderabad, and Ahmedabad, Pune, Kochi. So these are the visuals. Students, as I said, we held 1 or 2 students competitions as well. This year, notably, we have assisted one group of students to submit. Yeah, okay. So
Binoy in Rise, he was one of the key members in that competition. He is the dean of DY Patil College.
So we assisted. Of course, all the hard work was done by the students, but we acted as a conduit to facilitate their entry into CTBUH World Competition. Another feather in our cap is Amitabh Kumar, and he is now on Asia Hub Steering Committee of CTBUH. So we will India chapter will be represented there. In fact, we were just talking while having coffee that while he will be there in Singapore for this coming World Conference, he will be pitching for next, Thakur. Okay, but I hope they will come back. Rakesh Bhatia is there. Andreas, yeah, is there. Rohit Uchil and Suraj Nair will be, of course, hosts for all these speakers and panelists. Anyone financially, except the sponsors like Everett and Brunos. And there is no other revenue, no other source for finances for us. Sometimes we people pay from our own pockets and conduct these knowledge sharing events. Fortunately, we have some patrons who have also paid from their pocket a fixed sum, and they are our backbone. We derive from them the spirit, the finances, and all that from time to time. But we are also trying to open our patronship, and the benefits will be if you pay for an individual person, you pay 1 lakh rupees, you will be invited to all these events free of cost for next 5 years. And if you are going to have a corporate patronship, this is only patronship. You are not trustee or nothing. You are just supporting with the help of your resources. So if you pay 5 lakhs of rupees, a corporate patronship, for next 3 years, 3 of your representatives will be invited free for all the events. And you will be our permanent guests for all the events. So that's keep that in or at the back of your mind to support this cause. Whatever balance we get from such events, all that money goes into conducting events for lay people and students. For students and events, we don't charge anything, not even from sponsors. So all the balance money goes for those students' activities. So keep that in mind. That's a good cause, and hope you all support us. Now, one more thing I want to tell. We have introduced this registration on Clubot link. And although you have registered, you have clicked on the link and you were registered, but there is a process in which you have to go right till the end so that we can send you tickets. Now, I know that audience for every events are different because our events are discipline specific. Today it's plumbing, so most of the people concerned with plumbing are here. But still, we want to tell you in future if we invite you how to register for our events. So I invite Akshay to explain you how to do that. I am going out, not coming back, so thank you very much.
Thank you, Akshay, for the brief explanation. And also thank you, Girish sir, for that wonderful introduction to our seminar today. It was a pleasure to know about the various undertakings that the team has been working on in the past years. Moving on, I would like to call upon today's guest of honor, Ms. Tejashree Joshi. Tejashree leads environmental sustainability at Godrej and Voice Manufacturing Co. Limited. With over 20 years of experience, she has facilitated strategy development, target setting, and achievement under Godrej and Voice's sustainability initiative of goods and green vision. She represents Godrej and Voice in the India Plastics Pact initiative and is also associated with India Business and Biodiversity Initiative, a flagship program of CII for mainstreaming biodiversity consciousness in Indian businesses. Let us welcome her with a big round of applause.
Good evening, ladies and gentlemen. Uh, Let me first begin by apologizing to all of you for being late today, for being not being able to reach on time rather, because I left my place of work quite early to be here on time. But unfortunately, it's one of those things in Mumbai which you really don't predict when you're on the roads. Nonetheless, I would like to first thank CTBUH, particularly Anuja, who actually approached me for this, and I was a little surprised that I'm here as a guest of honor and a speaker, to a keynote speaker kind of. Uh, but I would be telling an interesting story on particularly the topic being water. Something that you have the right intent, what could be achieved, why you perceive the goal of water management in whatever you do, in small or big ways. Nonetheless, I think all of us are quite synced into the fact that, and we all believe, I understand, that every drop counts when we are talking about water conservation. And it really does. Other thing is you need to have patience when you are following these particularly any of those initiatives or goals that you seek on sustainability or environment. It needs patience. You need to believe in what you are doing, and therefore, and then you see the difference. Or even if you put some numbers to what you have been able to do over a period of time, you would yourself be surprised of the impact that it creates on the society. Having said that, let me begin this presentation. I don't need to, this is an elite audience, a very enlightened one, so I really don't need to put forward what is the importance of saving water. Nonetheless, I don't think I can begin the presentation without still saying something about it, and bear with me, although you may be knowing what I'm saying or talking about. So, but while we go through the journey, I'll just share what we could do in this as an organization, and it's never late to start. Uh, we did start quite early, but in whatever small ways we can, in our own, even in our own personal capacities, we should understand this is one resource, which is life. And whatever you do to conserve this resource, it is worth it. The reason being, we know invariably water is not priced at its real value. And therefore, there is a huge amount of wastage, negligence, and apathy towards conserving this resource, which otherwise we show towards energy. But just one sentence I'll say before we go into the presentation, that you can generate energy, you cannot create water. It just has to be there. Only you can change it or refine it or purify it or make it change from one use to other. We do not have the capacity to create water. Therefore, it becomes very important, and we only realize the importance of this resource when it is not there. When it is there in our taps, we are wasting it, but the day there is no drop in our tap, we start realizing how important it was and why what we could have done to probably not come to the stage where we are not having water. So, of course, water, life. Why is it needed? No need to elaborate. Not only for ourselves, but for all our purposes, all our economic activities, everything that we do. It is based on one important resource other than the others which are based on this resource, and that is water. So, again, I think these statistics speak for themselves. We have read through them so many times, and we know there is abundance of water on the planet that we live on, the blue planet. But how much is available for our use? And if you just put a comparative, what everybody says is the earth has 100 liters of water. All that is available for us is a teaspoon. That's it. Because most of it is non-potable. Whichever portion is potable is locked in glaciers, or it is the groundwater. And today we see how much of energy we spend on extraction of groundwater, and we are also depleting that resource to a very, very dangerous level. Particularly, many pockets of India are stressed today on the groundwater levels. And then, what is available for us is the surface water, that is, which is there in our in the lakes and the rivers. And what is the condition of these water bodies? Everything that we create, we dump into this. So ultimately, what we are doing is harming our own water resources, and we are contaminating those water resources, making it non-potable or non-usable, and then spending a lot amount of money, energy, and effort to repurify it back for our own use. In the interim, we cause a lot of harm to all the other living organisms along with humans. Because of the contamination, we are spending crores and crores of rupees on mitigating the health issues that get associated because of these contaminations. And I'll come to it shortly. But why is all this happening? I think this is something we have seen very basic in our schools, the water cycle, the hydrological cycle. But is it that simple today? It is not. What has been added to this? The urban water cycle, what we would say. And it all starts from how it impacts the activities that we as humans do and how we impact this resource. So many times, whether it be land-based planning, there are changes because of what we do, and then what happens because of the water scarcity which is created due to land use planning and land use change, and then we lose water resources while doing that. Housing, we all know, huge impact, a resident and a domestic impact on water availability, as well as contamination is used. Health, it leads to health aspects because contamination leads to diseases, and diseases lead, and then it leads to a lot of spends and the load that it puts on the exchequer in terms of mitigating when there are cases like what we've seen, the epidemics, pandemics, or anything even that happens locally, is a huge burden on our economies. Waste is another aspect which, if ill managed, end up in all water bodies, and we today are seeing the issues of plastic ending up in oceans, ending up in our food chain. Also, I just read a report that there are Japanese scientists have discovered that they have discovered microplastics even in clouds. So it has gone to the level that the contamination we can't even imagine today, and it is all building up in our own bodies. So therefore, it is us whom we are affecting because of our own ill management. Energy, so much of energy use. Everywhere we are seeing escalation in the level of energies that we are requiring. But how is the energy generated? What is the biggest consumer of water when it comes to as an industrial sector? And it is energy. And while that energy is generated, what happens is that entire water which we are using there, most of it is lost because of evaporation. Because large part of the water used is cooling. And that we have to understand that the more and more energy that we are going to use, we are requiring more and more water. And agriculture requires, in India, agriculture is the largest consumer of water. But with the ill-managed agriculture techniques, there's also a lot of misuse and wastage of water which happens in the agriculture sector, along with the misuse and wastage of energy. And both are interlinked. You cannot see one in isolation, it always correlates. And then everything boils down to our economic development. Economic development is heavily dependent on this resource, availability of this resource, but at the same time, the scarcity or the levels that decreases in a concentrated economic activity impacts the availability of this resource, which inversely affects the economic development. We have heard many examples that power plant is shut down because of scarcity of water, or many times water lifting permissions are denied because there are no monsoons get delayed, and the first priority of water lifting in the river is given for domestic use, for an agriculture use. Industry or economic activity comes the last. And these disruptions we have seen in the industry, and we have seen that over the years, and which is aggregating more and more. And this is happening because of the mismanagement of water resource that we have. Now, this is not a local issue. We all understand the issue is global. But how severe it is? Water issues, nearly 4 billion people experience severe water scarcity at least once a month each year globally. At one point of the time or other, this is experienced by everyone. 2 billion people live in countries where there is water supply is not adequate for their requirements. And these are all like World Bank reports or UN reports which have done research on this. Half of the world's population could be living in areas facing water scarcity by early 2025. And I think why 2025? Today also we are seeing a lot of places this is now coming as one of the most important aspects and leading to a lot of migration, and water from being an environment issue has moved towards being a social issue now. If you see the World Economic Forum's reports, which comes out on world risks, water risk has moved from being only an environment risk to a social risk. And the reason being it leads to a lot of migration because of non-availability or because of flooding or because of erratic climatic conditions which are leading to water-related natural disasters. So around some 700 million people would be displaced by intense water scarcity by 2030. That's the kind of impact it has on communities and the most vulnerable sections of communities, the women, the children, and most vulnerable people in the economic strata of the society. So around 2040, 1 in 4 children worldwide will be living in areas with extreme high water stress. And this is what we are leaving for our future generation, unless we take action now. So what are we eliminated from this? Of course not. So India hosts nearly 18% of global population, and I think, we all of us know now we have the highest population in the world. But what is the water quantity that we have? We just have 4% of the water resource globally. So look at the stress on these water resources that we already have. So if you look at what is defined as a level of international threshold for water scarcity, which is 1,000 cubic meter per person. Today we are just at 1100. We are almost near the brink. We are already a water stressed country. When India got its independence in 1947, India was a water surplus country. Israel was a water stressed country. What is the status today? Israel is exporting water. It is a water surplus country, and India is a water stressed country. And why has this happened? It's not that our resources are depleted. It is that we have not managed our resources the way we should have. Well, probably if something is in plenty, you don't really value it. And that's what the syndrome has happened for us, unfortunately. But I think we'll have to wake up to the reality and come to our senses and take very, very quick actions on what we could do about this. Water scarcity, India only has 4% of water fresh resources. I already said this. Another important aspect what is affecting our water resources is water pollution. Now, good water sources are becoming non-potable or non-usable because of the pollution that is caused because of many activities, not only industrial activities, pesticides, by insecticides, so on and so forth. I mean, the pollutants are endless, the source is the same, and it ends up in the same place. Therefore, we are making it more and more complex for making this water back as usable. And we are only incurring more cost for treating and making it potable back for our own use. Groundwater depletion, the whole green revolution. Now today, industries which do not have water as a source, open water body as a source, depend on groundwater as a primary source of water. Large part of rural India is actually dependent on groundwater as its primary source of water for drinking. Over extraction, without actually taking mitigation measures in terms of replenishing back this water, has led to severe reduction in our groundwater sources in most part of, if you say, in most part of India. And groundwater depletion actually is have created many pockets which are overexploited or highly critical zones in India. And you would all know that Central Groundwater Authority is heavily regulating the extraction of water now. So industries who are earlier located in places like Chennai, if you know they are already overstressed. You do not get any permission for extracting groundwater anymore. So this is leading to disruption of businesses, which were not estimated a few years back. And industrial activity to shift from one place to other, what cost it has to bear. Climate change is another big factor which is affecting the water sources. Either there is contamination because of floods, or there is reduction in water available because of droughts. Either ways, we see this phenomenon alternatively nowadays. Either there is a drought or there is heavy rains and heavy downpour, and because of which flooding happens. In fact, we see the same thing during the year's time itself, but to wait for another year. And then to aggravate that, there are other global issues like the El Nino, La Nina. So we keep on fluctuating between different aspects which are still leading to the same outcome, and that is unpredictability of weather, which is leading to climate crisis, which is triggered by climate crisis, and making this resource more and more unavailable for us when we really want it. And then there are disputes. Why interstate? Today the disputes are between neighbors. So when they say the third World War will happen on water, it won't be between countries. It would be with your neighbor. It would be with somebody you already know, because you're fighting for the same resource. And that's where it leads that this is the biggest conflict zone that is happening today worldwide. And like I said, it doesn't have to be between states or between countries. It is just within the communities itself. So, what are the causes of this water? And I think I have covered it, so I will quickly take you through this. Climate change, you have already mentioned. Natural disasters are altering the resources or sources that we have for water. Wastewater, again, contamination. Another important is water waste. What is the wastage that is happening in our systems when we are making water available for the communities? Old infrastructure, breaking down of pipelines, leakages, so much of good resource which is not non-good, something a term that in the plumbing industry we know is non-revenue water, which is not leading to its end use and its rightful use. So much is lost in pilferages, so much is lost in leakages, that there is no account for it. On an estimate, if you see an old infrastructure, at least 40% of the water is lost because of leakages or water pipeline leakages that keep happening from time to time. And this is a criminal waste because it is depriving a large section of society from having this resource available for itself. Lack of cooperation on shared water resources. Again, whether water should be on the state list or the national list or the concurrent list, whichever way you look at it, there has to be a dialogue for resolution of this resource, because nobody can claim its own ownership on any source of water. In India, why is water not charged the way it is charged worldwide? It's because it is believed that it is the Almighty's gift to humanity and we have no right to charge it. But it has also led to wasteful use and non-realizing of the importance of this resource, which has contaminated our water sources, where we should be taking taking care of it as per our traditionally what we have been taught. Nonetheless, lack of infrastructure also is one aspect where water is not reaching every area. So the world crisis has showed that water issues are persisting and they are going to increase day by day. At the same time, this can be only managed by proper water management and conservation. So to do that, what we have to do is also, I already mentioned this, what is the water sources available and what are the impacts it is having. So for water management, we need to have a process of planning, development, managing of water resource in terms of both quality and quantity. At the same time, we'll have to look at all the aspects where this is required, including cities, townships, institutions, infrastructure, incentives, both on fiscal, non-fiscal, promotional, on policies. Every aspect needs to be looked at today for better managing our water resource. Now, there are policies in place. The world has taken notice of it. Many policies have been crafted at the world nations and other bodies like the United Nations. The Sustainable Development Goals, you would have heard about them, essentially covers water as one of the Sustainable Development Goals, availability as well as protecting these resources as life on water, below water, on land. Everywhere water is important. There are other water action decades, the Global Accelerated Framework, also specific conference on water in the United Nations. But these are all conferences, and you should always take it with a pinch of salt in terms of how much gets translated in implementation in the nation countries of the United Nations. There has to be national policy frameworks on this for effective implementation. And not only at the national level, but they need to translate at the state and the local body level. India has also put forward its policies on water, and there are many initiatives now the government has taken. We have a national water policy. We have the Jal Jeevan Mission to take water to every household. We have the Atal Bhujal Yojana, which talks about regenerating the groundwater resource. Then we have Swachh Bharat Abhiyan, which actually helps us to understand the management of waste which is leading to contaminating of water resources. The National River Conservation Plan, and you also know now there are plans on wetlands management and conservation, which is another source of water which also sustains life. So while there are also plans on the management of forests, because forests are believed to be the genesis for our water bodies and streams, and therefore conserving those forests is very essential for protecting our water sources. And this, while there's a recognition at the government level, again I say the implementation is where I think we lack a lot, and we need to improve as a country. Now, this is very simple. We all know this. While efficient water use, water wastage reduction, I already mentioned about that. Recycling and reclamation, which is one resource which we are throwing out if we are not treating and using back. Today, you would have heard about the zero liquid discharge term, particularly used in industry for ensuring that the resource, that your dependency on external entities for the supply of water is reduced to the maximum extent, so that you mitigate those, at least a large part of your use through the recycling of wastewater in your premise, rainwater harvesting, which is augmenting or which is actually replenishing the extraction that you have done for your own use. And there are methods and ways this is done, and I would actually like to take you now through some of the initiatives that we have initiated as an organization who has always been conscious about our impact on ecological footprint. Virgin Voice is a 126 years old organization. It has its headquarters in Detroit and having presence in 10 different industrial sectors with 14 businesses with an employee strength of about 15,000 and spread across the country. And these are not business units, Voltage Locks being one of the first businesses, including construction, including infrastructure business, and Voltage Aerospace, recently being one of the participants in the Chandrayaan mission. So it's a very different plethora of products that are manufactured and the services that are provided by the organization. But the philosophy in terms of how do we pursue our business is consistent across these 14 business units. And you would see something interesting here is values. As values, environmental stewardship has always been a value for the organization, not today, but for decades. And this has been recognized as one of the most important aspects we need to follow, as important as integrity, building trust, respecting everyone, and customer centricity. This is one of the basic values we need to follow and we do all our business. Now, there have been many pioneering efforts that the organization has done in terms of environmental sustainability. Be it one of the first company in India to introduce ozone depletion substances free refrigerators. Way back in 2000, when the first time the Montreal Protocol was getting implemented in the country. The first company in the world to produce air conditioners with zero ozone depleting substances and minimal global warming potential. Today we are talking about global warming. The company took this initiative of transitioning to a refrigerant type with a minimal global warming potential way back in 2000, almost 20 years ahead of the industry. We were instrumental in bringing the whole green building movement to India. Mr. Jamshed Godrej is the permanent chairman of Indian Green Building Council. He has been advocating this principle all throughout the country. And today we know through the IGBC, India has the second largest footprint of green buildings. A huge impact in terms of water conservation, not only water conservation, resource conservation in terms of energy, material use, and many other aspects that are addressed by green building design. And therefore, this has been a pioneering movement in transitioning the bid space towards being more sustainable. The first net zero building under the Indian Green Building Council is in Rangoli campus, which is the first certified net zero energy building. We work with the World Green Building Council to promote net zero in the Asia Pacific region. And you would see we have tried out the first industry-led initiative on recycling of construction debris as back as a raw material in construction space. And these are a few examples. Over the years, there have been multiple examples. And while this has been followed for decades, our formal journey began as for sustainability in 2007 when we signed the CIS Code for Ecologically Sustainable Business Growth, the Mission on Sustainable Growth, which brought in an aspect of target-based approach for achieving environmental sustainability, from which was derived our framework, what we call as Good and Green. And one of the pillars of Good and Green is creating a greener India through our operations. And under the greener India, we have two very important targets here. One is reducing our specific water use, and the other is creating a positive water balance. And now, when we talk about positive water balance, it's going beyond net zero. Today, you see a buzz term called as net zero, where you are mitigating your entire footprint. This is going beyond net zero. So, water efficiency being one of the important focus areas of our sustainability journey. This is how we drive water efficiency across our manufacturing locations throughout the country. Water audits for every process and utilities. Use of low flow fixtures, building in efficiency and reducing the water use. 100% treatment of wastewater generated within our premises. Adopting zero liquid discharge principles. Optimizing recycling systems performance. Maximizing the utilization of recycled water in every use that we can. And maximizing the harvesting of rainwater for the potential of any of our establishments. And all these locations are zero liquid discharge and having recycling of wastewater entirely through in our processes and other applications. Now, how this can be done? Various aspects. Water recirculating within the process. You find out avenues where you can recirculate water so that use of fresh water is used. Very simple, change of taps to low flow fixtures, rainwater harvesting I already mentioned. Enhanced or advanced treatment of wastewater to make it good for use back in process and not just auxiliary uses like flushing or cooling or landscaping, and other uses as well. So the campus in Vikhroli today recycles more than 12 lakh liters of water every day, which forms at least 50% of our entire water footprint. And that's the dependence we have reduced from an external water usage point of view. And this is also replicated across our premises. Like in Chennai, which is a very water stressed area, we have implemented everything that we could do, not only recycling, zero liquid also 100% capturing of rainwater on the premise and percolating it to the ground. Now, we have also taken this beyond our campus to our colonies, where we have actually retrofitted two colonies hosting around 3,000 tenements with the sewage treatment plant and recycling this entire water back for flushing through automized pressurized hydropneumatic systems, so that there is no human intervention with this treated water, which is only goes for the purpose of flushing and nothing else, so that you will eliminate that risk of people coming in contact with the recycled water. Rainwater harvesting, simple, maximize the catchment capacity, efficient water management, assessing the extraction potential and impact of the premise, real-time groundwater level monitoring, monitoring your extracts continuously, capture or substituting any use of this water, and obviously groundwater recharge, because that's where from where you are drawing the resource. And these are some photographs we have tried to capture every place from where water can be captured in the campus, not only in Vikhroli but elsewhere, everywhere where we have our factories. What I want to emphasize is what mechanism you use for rainwater harvesting depends on the locational conditions and has to be designed accordingly. Somewhere we are capturing the water and reusing, somewhere we are percolating it to the ground, somewhere we are using a combination of both, because that is suitable for that particular location. We have also tried out new techniques or innovations in terms of water capturing and harvesting, and also going to the level of improvising or reducing our water use, even for the uses like landscapes or irrigation. Monitoring of groundwater, post-monsoon, pre-monsoon, that gives you real-time data and know the level of what is the impact of your initiative. At the same time, helps you detect if there are any risk areas. Also look at operational efficiencies even to the smallest level. If you are making a solar installation, the use of water for cleaning the installation is one big aspect. So we have gone to automate this by using sprinklers and timer-based automation, where the water use requirement has come down by 30%. So you can identify every small aspect where water efficiency can be built in. So what has this created? The reduction in freshwater use by 59% over a base year, and the recycled water and rainwater harvested that we have achieved over this period is equivalent to suffice 345.9 million persons water need for a year. So if you start putting a number to what you are doing, then you will know that you are on the right path. And I will encourage each one of you to have that monitoring for your own activities, which gives you impetus to go ahead. Just small recommendations of what we can do when we are talking about efficient water management. Let's look at both the demand side management, design, and supply side management. So when we talk about demand side management, look at water efficient devices, optimize frequency of cleaning activities. These are all day-to-day activities that we do. Optimize water use in gardens. Plants do not need flooding of water, which is a misnomer. They need very specific water at their roots, only up to a specific quantity. And it's best to water plants not during the day, in the early morning or evening, so that the evaporation losses are reduced. Design and supply side management, water pressure optimization. A lot of time, this is the basic cause of water wastage in our systems. Incorporating dual plumbing systems during design. Individual dwellings monitoring with smart meters. Today this is possible. This gives you visibility of what is your impact as an individual tenement or individual household. Wastewater or grey water recycling, as the case you would like to do. Rainwater harvesting I already mentioned. Again, the design side, a little bit in detail. Install hydropneumatic system, it's much controlled, reduces energy usage as well as water. Install pressure reducing or flow reducing devices if they are not already part of the design. And then other measures that I have already talked to you about. Rainwater harvesting, rooftop harvesting, either recharge to the ground or store and reuse. As a thumb rule, if you have one bore well extracting water, you should at least have 4 wells to recharge it back to the same level of aquifer from where you are withdrawing the water. That is because you only have rains for 3 to 4 months, but your extraction in mind. But of course, this is a very, very broad term rule. This needs a study, and based on the study, it is recommended you go ahead with the rainwater harvesting aspects. Grey water recycling, the costs, the costs are not so high as we think. If you actually put a true cost water, it would work out that the recycled water is much cheaper than the fresh water, and that the experience in industry, when the water is charged at a much higher rates than it is charged to residents. So these are some basic things that we can do. I would just end by saying that when we are actually building communities on the needs of the present, we need to cater to the requirements of tomorrow. And therefore, they also need to transform and adapt to the changing needs of its inhabitants and residents or users. And they need to sustain and last for decades. Therefore, resilient communities need to be socially conscious, environmentally responsible, self-contained, dynamic, responsive, transformative, as well as being futuristic. So, small transformation. This is also a manufacturing plant, but when you redevelop, be conscious about how you are redeveloping. This is a platinum rated green building. Attempting to minimize its impact on the environment when its retransformation has happened. Thank you so much for listening.
Mr. Amit Thakur would present a memorandum to Tejasvi ma'am. Moving on, now we would like to have a presentation from our sponsors. I would like to call upon stage Mr. Andreas Museva to give us a presentation on
Thank you very much, and good evening everyone from my side. My name is Andreas Mosebach. I am German, born in Stuttgart. I'm married to a Swiss. We have 3 little kids and we live in India, so quite a long way to come here. I think I get the applause for that. That is nice. So the applause should go to my wife, not to me, because she has a tough job living here with 3 little kids. So we live here since 1.5 years. We are located in Bangalore. I have been in Mumbai so many times. Until last weekend, the only thing I have seen is offices, construction sites, the airport, and some hotel. So since I'm traveling a lot here, my wife told me, and also the kids, they all want to come to Mumbai. So last weekend we came here, and the first time I have not seen construction sites, but I've really seen the city. We were in South Mumbai visiting the Gateway and the Taj Mahal Palace. We went to Leopold Coffee, so such a big history here in Mumbai. I really like it. So I thought I would also tell you, I asked our little kids what they loved especially about Mumbai, what they liked. So our oldest son, he's 4 years old. He told us, we visited the railway station, Central Railway Station, terminus. He liked that a lot, the trains and a lot of things happening there. Second thing he said was the breakfast buffet in the hotel. And it was because there was such a huge things you can choose. And he was choosing to eat cereals, same thing he's eating at home, but he loved the buffet. So then I asked our daughter, she's 2 years old. So she told me she loved that in the airplane she was allowed to eat chewing gum. That's what she loved most about Mumbai. But we really enjoyed to stay here. And Mumbai is a great city for sure, and my family will also come back. And I'm happy to be here tonight to speak with you about sustainable training solutions for high-rise buildings. So Mumbai is a perfect place to speak about that because there's a lot of high-rise buildings. So when I speak to my working colleagues back in Switzerland, you know, the highest building in Switzerland is in Zurich, the Prime Tower, and it is 30 stories. So for people in Switzerland, the high-rise building, very high high-rise building is the 30 stories building. So I always tell them you have to come to Mumbai, because in Mumbai we even don't call it a high-rise building, which is 30 stories. But you can only grasp it when you drive through the streets here. Really amazing what is happening here. So, yeah, nice topic. So, at Geberit, we of course we are really focused on sanitary solutions. Next year we are turning 150 years, and we study a lot about plumbing and especially drainage as well. So what we found out speaking to people in different countries and different customers, be it developers, MEP consultants, PMC architects, contractors, installers, plumbers. What is the challenges for drainage specifically we are facing in high-rise buildings today? The first thing, and that is the reason why we build high-rise buildings, space is limited. In here in Mumbai, we see from 3 sides we have the sea, so we have to go vertical. So that's because of space. Space is very limited and it's also very expensive. If I tell working colleagues back in Switzerland what you have to pay for an apartment in Mumbai, they get such a ice. Because you don't expect that the same price is what you would pay in a city like Zurich. Planning is often very complex. It would be very nice if the drainage stack would go down simply vertical from the 50th floor. I see some people laughing, right? That will never happen, so planning is very complex also for drainage. There's a risk of leakages, and this risk is not only there in high-rise buildings. In the house I live, back in Bangalore, looks very nice. But I think in average once a week there's a plumber because there's some leakage. But then our house is still easy to fix because it has 2 stories. But then in a high-rise building, if you have leakages, so many people living there and such a high amount of use, that the risk of leakage is higher, and also to fix it afterwards and the impact is quite high. And the last thing which connects quite good, I think, to the topic you have got, there's a trend to water-saving technologies which we all have to do. That also has an impact on the drainage system itself, that we use less water in the bathrooms. So waste of space for pipe installations. Here you can see on the picture a conventional drainage system, how we would use it in a high-rise building today. And there we use 1 pipe for soil, we use 1 pipe for waste, and we use a ventilation pipe. 2 of them are diameter 166 inches mostly, the vent pipe is 4 inches 110. So large pipe diameters, 3 pipes, and that requires a big shaft size because simply need that space to fit the pipes. That's a challenge in high-rise buildings because we don't have space. The second topic I want to highlight a little bit what is a challenge when we look at water saving, when we look specifically at the toilet, which is one of the biggest consumer in private households and residential buildings. Also, where we have seen, I think, the biggest reduction over decades. When you look some 4 or 5 decades ago, one person per day has used roughly 70 liters per day for toilet flush. And we have reduced that, year by year, decade by decade, and today we are at 14 liters per person a day. So that calculation would be that we have a dual flush system, so in a small flush. In average, one person is using one big flush per day, and 4 small flushes per day. So that reduction of water volume for the toilet flush also has an impact on the drainage system. So that is the challenges we face. Stack concept, so reducing from soil and waste inventory pipes to one pipe, how that works, how we can address those challenges in high-rise buildings, and also what is the other sustainable impacts that we are having with such a system. Speaking about stack concept, so very simple from a conventional to a single stack system. The name single stack already says it itself. It's one stack. It's a single stack. We are reducing from 3 pipes to 1 pipe. It sounds quite simple. It's not that simple, but it works perfectly. So later, when we have the network dinner and the coffee dinner, we have a booth where you can see a live model how the water runs inside the pipes and how the concept works. So we are reducing from 3 pipes to 1 pipe. So very interesting in Mumbai, in a lot of buildings, the space is already so small for the shafts, it's even not possible anymore to do with the conventional system. We are already forced to do with single stack system, there's not enough space anymore. So that is a single stack system going from 3 pipes to 1 pipe. That leads to space saving. You see on the left side, that was the initial picture of what we need in a shaft. If we only go with 1 pipe instead of 3 and smaller pipe diameters, we can reduce the shaft size. Or if we have other services in the shaft, we have more space for other services to run inside that shaft. So the benefit is less space requirement. That is at the end, the first part of the sustainable drainage, using less space for drainage. Because a sustainable building, I would say, is also a building where most of the space that is there is used actually for living space, not lost, like a dead space, especially for the background pipeline. So how to plan that? It's, it can stay a concept, but if it's only a concept, it will not work. How does the planning actually look like? I will show you some examples how the planning can look like. So you see in the middle, you see the conventional, the dual stack system in that case, and on the left side, you see the single stack system. So we start with one standard fitting that we can use, a swept entry fitting in dimension 110. Here, instead of using, in that example, 0.24 square meters space that is required, we can reduce it down to 0.13, or with a clever planning even to 0.09 square meters. So 40 to 60% space less required in the shaft compared to a conventional system. So the next thing that we can do here, we have still connected 1 bathroom to 1 pipe, which is also the conventional way. We can go to something that is called a back-to-back toilet. So often in buildings we have a shaft in the middle running, and then on the left side and on the right side we have a bathroom, maybe even on the back, and on the left side we have a bathroom. We can also combine several bathrooms into 1 stack pipe. So the example we can see here on the left side, we can see there we have even 3 full bathrooms and 1 guest toilet with a toilet. And a lot of pipes needed. I mean, you can see it in 3D pictures. You can even not identify the pipes anymore. That is an interesting case because in that case, it was even not possible to accommodate all the pipes for a conventional system. We had to go with a single stack system. So here we have combined all the 4 bathrooms, all the 4 toilets, 3 full bathrooms and 1 guest toilet into only 1 pipe, which is a diameter of 110. So first of all, our customers
was able to accommodate the drainage piping itself inside the shaft. The second thing is there was gain of a lot of space for other services which could also run the same shaft. And the system is working perfectly fine. So here you see the details of that we only required one shaft, and the size we required was roughly 470 by 250 millimeters only to accommodate the stack pipe to drain 4 bathrooms per floor. And that was a building with more than 30 stories where we could realize that. So with that concept of so-and fitting, where you have multiple connections and a higher capacity, we can connect several pipes to the stack. And here the example you can see is again in the middle, the dual stack system for one toilet would require here 0.24 square meters, so in total 0.48 for a back-to-back toilet for 2 bathrooms. And we can reduce that with the single stack concept to only 0.28 square meters required when we connect 2 bathrooms, or even more to one stack pipe. So it's again roughly 40% of space saving over the conventional system that we have. So we can really accommodate more services in a shaft or reduce the shaft size. So now what is required in the planning process, in the planning procedure to really realize that? First of all, the shaft size. So the shaft size has to be minimized at an early project stage. So if we only think about that at a very late project stage where layouts and everything is fixed, we had some projects where the customer even decided to go with the single stack concept, but the shaft size stayed the same because it was simply too late to reduce it. And now we are seeing more and more projects where the people really sit together at a very early project stage and discuss about what is really the shaft size required and can we reduce it, because it's less space than what is normally what is in our mind, what is needed. So one thing is, for minimizing, it has to be done at the project stage, and a coordination is needed in between developers, architect, and consultant. And we as a company, how we handle it sometimes, we invite all the people in a early project stage to one table, we put that topic, and then we discuss about it. It's always interesting discussions, those different people in one room, but at the end, often we find a good solution how in an early stage already we can use it. The second thing is, one is the size, the second thing is the positioning. So if we have several toilets, if we position the shaft at the exactly right location for the drainage, we can also reduce, one is the running meters, so we need less running meter of pipes, and also we can combine as many bathrooms as possible into one stack, and we have seen on projects that we could even eliminate complete shafts that are not needed anymore, because we could combine several bathrooms into one stack. That again needs consideration of back-to-back connection into one single stack pipe, and again coordination in between developer, architect, and consultant at an early project stage where shaft positioning is not yet fixed. If that shaft planning procedure is adapted, a lot of space can be saved in a project. So the first part was a single stack concept and how we can optimize the space needed in the shaft. So now what are other topics that make it sustainable? One big aspect is an improved carbon footprint because we have a lower material consumption. So when we speak about sustainability today, I think very often one phrase is used: reduce, reuse, recycle. And it's in that order. So the first thing we should think about is reducing. You spoke about reducing water consumption. We also speak about reducing material consumption. If we go from 3 pipes to only 1, or even from 6 or 9 pipes to 1, we simply need less material, which at the end also adds up in an improved carbon footprint, simply because we use less material. The last thing I would like to address is the water saving topic, because that has often, someone was saying it in the beginning, that we often don't think about plumbing. And we can definitely confirm, as Gabriel, who speaks a lot about plumbing, that often people don't think about plumbing. But it is very important, and water saving has a huge impact on the plumbing system, on the drainage system especially. And we remember the water reduction we had in toilet flush from 70 liters down to 40 liters. We also have the impact is not only using less water, it's also that less water is drained into the drainage system to flush out everything. And the reality in water saving is, it's really down to the reality. We can reduce the WC flush, for example, down to 4 liters. But if you put yourself into the shoes in your own apartment or house where you're living, I mean, I put myself into that shoes. If I'm flushing the toilet, and if not everything is flushed away or the bowl is not clean, I do a very simple thing. I flush again. So, I mean, I'm saying that now, my personal experience, but that's not only my personal experience as a giver. We have done a lot of study on that, because a lot revolves around the toilet for us and the plumbing. What is the user behavior when water reduction and toilets with less water flush volume are applied? And there's a lot of people that give the feedback. Earlier there was a bigger flush volume. Then they either moved into a new apartment or renovated the bathroom where they have a low flush toilet now. And they said, you know what I'm simply doing is I have to flush 2 times all the time. So it's a simple calculation. If it was earlier 6 liters and we reduced to 4, but we flush 2 times, it's actually not a reduction, it's an increase to 8. Or the other thing, coming back to drainage, if we reduce to 4 liters, but there's blockages all the time, what will maintenance team do in let's say apartment buildings? They will simply increase the water flush volume again, because they know if it's reduced, it's not working, we have blockages all the time, we have to increase it again. So very practical, we have to think about integrated product solutions. Space saving is one. The second thing is water saving solutions, but not only on reducing the water consumption by flushing less water, also by using systems that work as integrated product solution, that really the whole system works with less water. So that was my 3 points about sustainable drainage. One is to apply a single stack concept to reduce space in the buildings. Second, to also reduce material consumption with that. And the third is to use integrated product solutions and think holistically about a system that really works and where we can really save water. So thank you very much for your time. I would like to invite you afterwards during the network dinner. Of course, I mean, same, I also will be hungry and first eat something and drink something, but also pass by our booth. We have a very interesting hydraulic booth where we really have water running in transparent pipes, so you can see how a single stack concept works. And we also have a real size build-up of a shaft where you can see how 2 toilets, a back-to-back toilet, is really realized and how small that actually is. Thank you very much for your attention.
Thank you, Andreas, for that very insightful presentation. Moving on, Meghdut Pumps and Services. And I would like to call upon stage Mr. Harihan Singh for his presentation. Kindly, can we have a round of applause for him?
Very warm good evening to all. I'm Harihan Singh and presenting today Grand Force Pumps. I hope many of you know already Grand Force Pumps, premium and efficient system pump solution provider for the plumbing as well as for the HVAC along with the wastewater as well. Today we are going to talk about 2 solutions here. One is the HVAC and second is the plumbing. where how HVAC can be, possible for the high-rise building. When it comes to in my mind for high-rise building, we always think about first of the leakage. If it is going to be there, then what would be the challenges? And people sometimes go with the other solutions like refrigerants and all. So we are going to talk about the fifth generation technology, which is the DPS, distributed pumping technology, which makes it possible to work with the high-rise building in the HVAC. So starting with this core conventional system which is there in the market, and you heard about this like constant flow circulation system, which is with the constant chillers, then constant primary flow and variable secondary, then constant primary and variable secondary and tertiary, and the last one, fourth, is the variable primary flow system. Right? These are the four systems people are going to talk about in the market. And when we talk about this, certainly there is a lot of things coming into mind which comes as the challenges when we are going to put these kind of solution into the high-rise buildings. Right? So what are those challenges? We know one is the low delta T syndrome, right? Delta T issues, which always comes as a challenge when we are talking about the design IKW per TR, the efficiency, and when we are going to get it after the installations. The second is compromised indoor climate temperature oscillations, right? Especially in the high rise, because the temperature difference is there, air velocity difference is there. So when we are going to implement in the high rise buildings with the chilled water systems, we always get that the requirement is different at different floor levels, especially when we are going above 20th floor. Right? So maybe the temperature we are setting for the lower floors may not be required for the higher floors. What could be the possible solution for that? So this is one of typical challenges when we are going with the high-rise buildings. The third is time-consuming balancing and commissioning process. Now this is the another aspect. When we are going with the high-rise building, people always think like, okay, at the long shaft and the balancing wall where to put. So it really looks difficult when we are going with a spread building. It may be easy, but for the long high-rise building, it may be not that easy. So this is the another challenge. Complexity in design, installations, and commissioning. We all know when we are going with the VRB as compared to the chilled water system, the complexity is more. Low efficiency pump management, and that's we all know, right? When we talk about the BMS system today in the market, how many BMS systems actually working in 100% auto? When I say 100% auto, it means there is no person required to maintain the system, right? But today, we know, like, one person is sitting in front of BMS getting call like, okay, this place is having more chilling, this floor is not getting chilling or cooling. So those kind of challenges is always there. And the last is comfort cooling issue at the high-rise buildings. So that I already discussed in the compromised indoor climate. So what is the solution for it? We call as a distributed pumping flow system, which is not a new in the design. It is already there. If you see in ASHRAE, it is already there in spec. This is in the documents. But the possibility how it is with the Grandforce is we take that pumps, which is a kind of circulator. We call as e-pumps, a small circulator pumps, which makes it possible to make it in the field. So how it works really? If you see in the picture, the conventional system here. The conventional system here, you see a simple schematic with the primary pump and the chiller and the balancing valve, and here there is no balancing valve, only the pumps. And we show it on the screen. Well, how we can make it a screen? I'll just make here. So it's like driving a car with the speeder all the way down and controlling the speed with the brakes. Right? What we are doing exactly? We are maintaining the pressure at each and every level, and then we are taking the pressure to maintain the required flow in head. Right? Are you really want to do it on the road? No. Right? So we want that solution where we don't need to put the brakes. And that is going to give you the exact energy saving as well as the comfort cooling. So how we are going to do it? Instead of PIC valve or instead of control valve with the balancing valve, we are going to put a small circulators, which is almost a similar size of the valves, And these small circulators are going to take care of that particular AHUs or a sum of FCUs. And based on your actual requirement, actual means very much actual. It is not the estimated one which we are going to design during the designing stage. So it is a very much actual flow and head based on the AHU requirement. These firms are going to provide to the AHUs based on the cooling requirement. We'll understand more like how it is going to work and the further inputs like how it is going to help us in the high-rise building. But before that, a very important point is minimum pressure, maximum ceiling. How it is going to be a minimum pressure or how it is going to help us in a high-rise building, that we will discuss. And then there is a demand driven. So when there is a demand, then only we are going to provide the water to the AHUs. Now you see this a simple installation I just want to share with you so that one thing is coming to mind like, okay, where to put these pumps, this small water pumps. So the similar area where we are putting today the control valves or PHC valves, we have to put these magnets, small circulator pumps, and these are going to get the same temperature input, or if the smart HU or the conventional HU don't have the controllers itself, still we can take a simple temperature input and we can give it to these smart pumps. And these smart pumps is going to control your chill water side. We don't need to depend on the controller of the HU if there is no controllers for the HUs. So this is how we are going to place this instead of the wall. So now coming to the comparison, how it is going to work. Like in conventional primary variable system, if we are designing a pump, we have to design this pump till the farthest end. When I say farthest end, means the complete head of the building I have to consider, and plus the friction losses across the HU, across the walls. So overall static plus dynamic losses I have to consider along with the factor of safety to design this pump, right? But is it really required? Answer is yes for the system, because the system is like that. And if I talk a name pressure, it means in a closed loop, any closed loop, it is not for the HVAC loop. Any closed loop, if I am talking about the pressure, it means I have to do the balancing, right? And balancing is not an easy task. I hope you all agree. When we say balancing, and especially in the buildings, when it is going to come in a phase wise, like okay, I'm going to operate a 50% of it, and then after 6 months, a 50% of it, I have to do again and again. And I could ask you also, if you are going in the documents, each year we have to do the balancing for the efficient system. How many of us is doing? Right. So these are the some challenges with these systems which we are going to mitigate from this system. How we are going to do it? So instead of designing this pump for the complete circuit, we have to design this pump for this end only, which is the balancing line, and this balancing line is in the pump room only. So the primary pump which is going to fit to the chiller and maintaining the delta T for the chiller is only sized till this balancing line. And these all AHUs or the set of FCUs will take water from this circulator pump. Now this circulator pump is going to take water from this point, which is the balancing point, and circulate the water through this AHU. Now just imagine if I am going to the AHU manufacturer, AHU manufacturer says, okay, my delta P across the AHU is 6 meters. This is the design, right, for the 100% flow. In conventional system, I am designing this pump 6 meter plus factor of safety. And that is always available there, right? Now it is the AHU requirement to fill the pressure through the PIC wall or the control wall to take that water. But here, when I am going with the pump, this pump is going to take the actual delta T requirement and going to provide the actual pressure and the flow into those AHUs. So maybe the requirement is only 3 meters, right? So if it is a 3 meter, it means that's just proportionally, I'm reducing the power by 50%, right? And at the same time, I'm going to provide a quick input of the chilled water to the AHU for the comfort cooling, which is going to increase your response time on the comfort cooling. So this is the one. Second, what happens, suppose if I'm going with the high-rise building again, on this 50th floor, there is some issue. And I have to do some maintenance into it. But what I have to do in this system, I have to shut down the entire system because this is a one loop, right? Here, as you see, this loop is individual and there is no impact on the other loop. there is no impact to the third loop, and there is no impact to the fourth loop, because each magnas is making their own closed loop. If I have an issue at third floor, because there is only third floor, so I have only taken the example of 50th floor. If I have an issue of 30th floor, I have to do maintenance by closing this pump or the manual wall across. I no need to shut down the entire circuit of it. So this is the beauty of this system DPS, where we don't need to worry about the maintenance thing if we have any challenges with the system, that particular building. Pressure. So this is a very, very important part in the high-rise building. When there is a less pressure in the supply line side, less leakages can be occurred or may be occurred, right? Higher the pressure, we have to maintain the system in a very, very rigorous manner. And in this, we need to maintain only the field pressure. Field pressure is nothing but we have to maintain a pressure a little bit higher than the atmospheric pressure so that there is no air comes into the line, right? So that is the only field pressure we have to maintain there. Rest of the pressure which is required to provide the chill water to these AHU is being maintained by this pumps only, circular pumps only. Okay. The point number 2 is at no load condition, the air handling units and pump can be remotely shut down. So I don't need to charge each and every AHU at all the time. These all pumps are BMS or cloud compatible. Anyone can go through the system, or we can put the program also in the system. If system is not running, we can shut out it completely. So there is a savings on both parts, and there is savings on both parts when I say is the energy and the maintenance both. Right. So the each of using and the maintenance. Then the pump supply of the needed flow. I think it is 20 minutes. So then I have to go a little fast, sorry. So this is, I'll just then I'll jump on it because it's a little bit of a big subject to discuss over. How we can implement it. So as you can see on the screen, we always go with the heat exchanger when we have to split the pressure. So if it is 40th floor building, maybe at the 20th or 80th floor based on the design, we can go. And instead of going with the secondary system, we can easily go with a small circulator there. And by maintaining delta T, we can maintain the required comfort cooling in those floors. Now, what is the difference between the conventional system and here is, now these magnas are understanding the actual comfort cooling requirement at that particular level, right? So we no need to depend, or these magnas are running in the lower level. So they actually knowing what is the climate condition outside, like the temperature is down or air velocity is high, and accordingly we are maintaining the comfort cooling. Quickly coming on the water boosting. On the water boosting side, if you see, these are the normal load pattern, right, in the system. But today, if we see in the plant, many of the building, the high-rise, either the commercial buildings, we see we have the same size of the pump. Like this is an example of actual building, where we see these are the pumps, which is of the same size, same capacity, same head we have installed, and with the single PFD. Right? So when we are operating this and we put the 24-hour data into our flow meter, because we are an auditing company as well, we are doing the energy audits. So we have taken the 24 hours data, and what we got at 82% of the time, the flow rate was 0 to 5 meter cube per hour, whereas pump was designed at 10 to 20 meter maximum. So if you see the percentage, the 82% is the maximum one. We have not done something, very great in here. Only what we did, we just replaced this pump with a smaller pump, which is called as a jockey pump, and we put the multi-BFD system instead of the single BFD system. But just by doing it, we can able to save 60% of the energy. And not only on the energy part, to your surprise, with this system, we can able to reduce the leakages, we can able to reduce the energy, we can able to reduce the water consumption as well. So very fast, I'll just do just 2 minutes. So this is how it looks like. If you are going with the long range building or the high spread building, then it is better to go with the jockey pump system, so that a small pump can
operate the higher load requirement, which is the most efficient. Then the I5. Now the I5 is the thing which Gradfos has introduced first in the world, and till date there is a till 11 kilowatt I5 is there. What is the benefit of it? Why to go with the I5? Till I4, if you all know I4, till I4 the both rotor and the stator part having the coils, and there is a flux losses, right? What is the difference between the I5? I5 having a one permanent magnet, and that reduces the slip losses. And point is not ending there. With the I5, if you are going to operate the pump and the motor at the low load condition or the varying load condition, your efficiency is still intact. The losses is very, very minimum. So the answer is, one is the saving, instant saving, which is 2 to 3% maybe. That is not the true comparison. You have to compare it by taking in the load condition, the varying load condition, and then you will see a surprise minimum 10 to 15% saving will be there with the I5. And what Gradfos has did with this, we took it into the another level, because when we are going with the I5, you have to make VFD as an integral part of the motor. And we took the advantage of it. We added the condition monitoring there, because since we are going with the I5, we can upload our pump data, our pump curves into it, and we can do other advantages which can help in the dry running, cavitation, motor temperature, motor bearing, flow estimation. No need to go with the flow meter extra, and the status parameters. So these all things are very, very important when we are going to link it with the operation and the maintenance aspects. Cascade operation we all know, but maybe if we are not knowing it, cascade can be more efficient. How it is can be more efficient? When controller can understand, when I have to operate two pumps at what efficiency point. So those are the points. Yeah, just one. So cascade is the operation where Gradfos is going to give you a saving of 15 to 20% more by operating the same pump in cascade operation at best efficiency point. So this is again our subject we may connect during the good. Then the post switcher is same as the cascade. One very important point I want to discuss only two points in the last. The proportional pressure control. It is very important with the two aspects again, the energy saving and the leakage aspect, which is again a very, very important point. So here the dynamic losses. What we do know today with the variable system, the hydromatic system, we put our constant pressure settings, right? If we require 4 kg, 4 bar gauge, so we set up 4 bar gauge, right? But that is required for the 100% flow. If it is 50% flow, what should be the set point? It should be maybe 3.5, right? Because friction losses are lesser in the pipeline. Pipeline size remains same, right? So if I have some logic in the system, like the set point can change automatically. No need to change the set point manually. So I can save more, right? And at the same time, with the low flow, if my pressure is reducing, my leakages in the pipeline can be also maintained. So this is the proportional pressure control, which also called friction loss compensation is by default coming with the Gradfos system. And the last one is the monitoring non-return valve. So what is the main failure today in the market? Sir, my pressure is not coming, systems are running, everything is okay, but still I'm not able to get water, right? And when after the lot of exercise and study, we feel like okay, NRV is not working, water is just running near to the pump. So in our controller, we can able to show you the small leakages in the NRV, which is again going to increase your energy consumption as well as the failure to the motor or the pump. So if there is small leakage, the waiting alarm will be there, and if the NRV 100% defect, then alarm and stop pump is there. So with this, thanks a lot.
I would require you back on stage as Mr. I would also like to invite Mr. Rohit to present the memento. I would like you on stage for a brief moment.
Hello, I am back, although I promised I would not come on the stage again. But it's very important. One thing that has to be noted is we are not professional event managers, okay? And all our events are done by professionals, senior as well as juniors. And sometimes we need to have some kind of self-appreciation which will boost our own morale. But while the seniors don't need it, we have earned it through our careers and all that. But I want to call upon Ankita, Aditya, Amit Shinde, Sanjay Khanna,
सेंटर कर दे
Tanmaya, Karna, and Suresh. So as I said, this young brigade, they work without any expectation, without any remuneration in any kind. So along with my appreciation for them or our core group appreciation for them, if you find this event has been managed well, please cheer them up. Thank you very much. And thank you all.
Now finally, we would like to move on to our final part of our event, that is the panel discussion. We'll just have a 5-minute break so that they can set up the entire thing, and then I will introduce our panelists. Leader with a strong focus on technical services design and project management on diverse projects globally. He has spearheaded design and technical services of multi-billion-dollar hotel developments in Southeast Asia and MEA. He focuses on maximizing value for both owners and operators through design innovations and strategic business initiatives. Let's welcome him with a big hand. The next panelist I would like to invite is Mr. Rakesh Bhatia. Rakesh is a Senior Vice President at Ecofirst Services Limited, Mumbai, and is associated with them since 2010. Rakesh has an experience of 26 years and has worked on over 110 projects worldwide. He is a renewable energy expert and has substantial experience in business development for integrated design services, MEP services, energy auditing and retrofit program management, and sustainability services for net zero and healthy buildings. Can we have a big round of applause for him? And the last panelist that I will invite back on stage is Mr. Andreas. Andreas is a seasoned professional with over 15 years of experience in the sanitary industry. In 2016, he has joined the international product management at Geberit Group in Jona, Switzerland. Since 2022, Andreas is leading the technical department of Geberit in India. Let us have a huge round of applause for all our panelists for once. Considering the impressive lineup on stage, this
yeah, we are not coming on stage because very eminent personalities on stage. We'll stand down and we'll try to get them to engage with each other as well as with the audience. I think since the key topic has been sustainability and with the impact on water, I think I'll take the first. We'll start off with the with pumping as well as, so since you were talking about pumping and drainage, we'll start the discussion with Sandeep. Sandeep, can we get some insight from you on design of pumping systems? And since CTBUH is so much into dissemination of knowledge for especially tall buildings, and now when we are talking about tall buildings even in Bombay and in the rest of India, we are looking at 40-story, 50-story plus buildings. What would you have as an opinion as the type of pumping system that we could use from a sustainability perspective as well as economy as well as reliability vis-a-vis having a hydropneumatic system, a distributed system, a gravity system, having service flows, not having service flows, because these are things which are debated on every project, and I think the audience would be interested.
Thank you. It's been great to come back and probably have an enlightening session with all the colleagues here. In my working, the first tall building which I was fortunate to start work was in 1999. We did the ITC Grand Central Parade. And that was the first project which was, I still remember, 110 meter tall. And when we got onto the design of it, there was no internet at that point of time, very less accessibility to codal references, global benchmarks. We didn't have too much. But what I realized very soon was that a tall building is nothing but building typically of 60 meter, kept over another building of 60 meters, kept another over a building of 60 meter, and you can keep going as much as long tall you want to go. So a 600 meter building is 10 60 meter buildings sitting on top of each other. And as long as you are able to understand the concept of zoning, I think life is not that difficult as far as tall building is concerned. I never find it very challenging at all. The only crux is that as engineers we learn a lot with minimum pressure, but our fundamentals on maximum pressures are not very clear. So I meet a lot of young engineers and I say, fire hydrant, what is the minimum pressure? 3.5 kg. What is the maximum pressure? He'll look at the sky. You ask him what is the minimum pressure for the sprinkler? People would not know. What's the maximum pressure on sprinkler? Again, engineers would not know. The only thing which most of the engineers would know, 3.5 kg fire hydrant. And that's where I think the trouble starts. As long as we do not know in a blood pressure system, the cyclostic and diagnostic, what is the upper and the middle range, we are not able to understand the health of the individual. Similarly, typically speaking, experiences break the building in parts. How you smartly do is one part of the story. In a tall building again, we talked about water supply. Drainage is one thing which again mesmerizes everybody, thinking that a drainage is going 200 meter tall. By the time the waste goes and stucks the base is going to shatter off. Nothing like that happens. Because all the water flows in the periphery of the pipe. It's a hydraulic jump which you experience at the base of the stack. But you don't see a thud of the overall thinking, making extra things to be provided. I think the whole idea remains breaking the building into zone. And hot water becomes another critical thing for hotels and hospitals. Of course, hospitals are not more than 30 meters or again or 45 meters. When we talk about hotels, typically when you do hotels, and we've been fortunate to work on hotels up to 275 meters, 300 meter talls, not a problem. And Prem Saab is here coming again from the hotel fraternity, working in all kind of projects. I'll not take more time. Just one last input over here is when people talk about gravity and hydropneumatic, how many of us would actually understand very clearly that hydromatic is much more efficient, energy efficient than a gravity system. 15-second tip on that becomes is that when you put a gravity feed tank on the top of the building, typically 10,000 liters of water, you convert the entire mass of 10,000 liters of water to be transferred from the X location to the Y location, and then that mass of water is being utilized back into the building at various heights. So if you have a first floor receiving water, it actually increases the pressure all the way to the uppermost level, bring it down and then feed it there. In a hydromatic, the water gets lifted to the utility area where it has to be lifted to. So you don't really pick up the entire, so it's like you take a person, bring him a bucket of water, make him go up by the lift to the 10th floor, and then he starts distributing water physically downwards. You see the amount of energy which this person has taken to first take the water physically up, then bring it down to where it needs. In a hydropneumatic system, you give the person with the water bucket and make him supply only to the levels where he has to rise and supply. So I think typically it's very easy. In my career of 27 years, I've never found a problem. As long as we know the fundamentals of pressures, life is easy, it's fun. That is what is more important. Selecting valves, pipes, fixtures, and also the hydropneumatic system with hot water makes things absolutely amazing. I'm sometimes surprised. This is not that a difficult rocket science, but for some reasons, the concept not being clear of the pressures, this is where our engineers actually tend to go wrong.
Thank you very much, Sandeep. That was very insightful.
Absolutely. Thank you so much for your clarity on the thoughts that you have put in. For many of the engineers, I used to still believe, the gravity system is the most simplest, but you changed my thoughts also now. It's a good, valid take point. Question to Prem sir. You being a client, the expectation of the client is to engage all the best resources. You take care of all the stakeholders on the project. You're looking at the life cycle cost analysis, the operation aspect of building. What do you think is the most challenging from a hospitality segment on a tall building with respect to energy or your HLP considerations? What do you think, and what kind of measures do you put up in your requirements of project?
So what I believe personally and especially is, it starts from day one. What I call is profit by design. So building well designed, as we saw in the presentation earlier, the whole crux is to involve all the stakeholders in when you design the building. I've been working with almost all of you in various projects, and that is the approach we take. We involve all the stakeholders, and enormous amount of time is spent on designing, which takes care of all the pain at a later stage. And as we know, today in the hospitality industry, HLP is the topmost cost apart from the manning. And if you don't take care from day one, you will never be able to fix it.
Great, sir. Thank you so much. Great.
Rakesh sir, since your thing is on ecology and management, and the whole topic today is of sustainability in water and high-rise. Can you give us a few takeaways and real bang for the buck that we could go for to implement especially since we are in Mumbai, the context is very small footprints. So if we had to do rainwater harvesting, there's always that thought, do we do cisterns, do we do recharge, and if we do, can we recharge bore wells now? We're not even allowed to extract water from the ground. It's very difficult to get permission to do that. So what advice would you give to maximize from whatever minimum is available to us?
So we have been actually working a lot on the entire water cycle. So water doesn't start, as we saw in the case study with Godrej. Water doesn't start directly from the PMC water coming in, but there is a detailed study which we pick up on each of our projects. So many of the clients over the last 3 years post-COVID, we've seen that there is a lot of climate risk involved in projects. So we begin our work right from the climate risk aspect. So we've seen many South Mumbai buildings being studied for climate risk, which means that there is a risk assessment which needs to be carried out on the flooding aspects of the projects. We've seen many projects in the past, the transformer rooms going down in water, the basements getting flooded. So what we found is that during these audit studies, a lot of these risk assessments, if would have done correctly, the climate risk would have been avoided. So as a result, many of the clients have been asking us that, how do we mitigate those risks? So already the land parcels are very narrow, as we all know in the South Mumbai areas, but there could be a mitigation factor which could play a very important role. So that is one area where we contribute handsomely to all our projects. Second is, most of the projects outside Mumbai do not have the luxury of having incoming water from the source of BMC. So there is no source. What we have to do is first assess whether we are allowed to draw groundwater from the same property itself and what is the recharge potential. So for that, a normal study won't help us. There is a hydrogeo investigation which needs to be carried out. What does hydrogeo investigation mean is that there could be a suitable extraction zone for water, but not necessary that it may be a recharge zone also. So we need to find out which are the aquifers which are ready to receive water in that plot of land, and accordingly we design strategies. Most of the times it is found that in Mumbai city, no recharging strategy would work because already we are at a higher water table. But what we could do is have some storage tanks. So these are called emergency storage tanks. So
cisterns, you mean cisterns?
Yes, so for 3 to 4 months they could store rainwater, but it could become another source of water. For example, raw water tanks or like tanker water tanks. So it could be used for multiple purposes. So this has been our finding mostly in the city of Mumbai. But outside Mumbai, what we really found is that there could be suitable recharge strategies which could be worked out depending on the hydrogeo investigation. Now, hydrogeo investigation is not a simple study. You have to get into the hydrology of the rocks and the zones. Like that is one area which pays us handsome results.
So, could you just elaborate a little bit on this hydrogeological surveys that you do, and how do you go about doing it?
Yeah, so it is the entire plot of land is actually divided into a grid. So it is, for example, a 10 meter by 10 meter grid, and then there are certain suitable tests done in those grids.
So you do a bore, like a test bore?
Yes, and then we determine what is the kind of hydrology, what is the kind of rock which is available, whether that rock can be penetrated, is there an aquifer available where we can recharge it, what is the extraction rate, what could be the recharge rate, and ideally, as Tejaswini ma'am said, that 4 times the amount of water which is being extracted needs to be thought about. Many places we have found that there could be suitable zones within the building footprint also. So what happens is we have to keep those areas as water storage reservoirs within the building footprint also. So that helps us to retain the water and allow us to use rainwater harvesting strategies successfully.
Thank you.
Good reply, Rakesh ji. I think quite amount of answers have been come up on rainwater harvest strategy from your end, and complementing to the initial thoughts that Tejaswini madam have put through. Question to Andreas, I mean, you come from the Gabriel family now in terms of solutions. Almost 2 decades back, we started to understand Gabriel in this country with your first system, the concealed system being fixed up. What do you see has been the evolution of Gabriel solutions for the last 2 decades, and what do you think you have come up with in terms of new solutions for the last 2 decades, and that this country has been witnessing from Gabriel solutions?
Thank you very much. So before I answer to that question, I would like to add up to Sandeep, if I'm allowed. So
yes, please go ahead.
I think you're absolutely right what you're saying, that a high-rise building we don't have to be scared of because it's high. And the same we were saying for for your systems, it also applies to drainage. So in drainage, actually, I had, since I'm here in India, but also before, I had a lot of discussions where consultants or developers say, you know, I'm very comfortable to use single stack up to 40 stories, but now I'm building a building that is higher than 40, now I'm scared. But then when you look at the drainage stack, there's a terminal velocity, and after 35 meters, roughly, the maximum velocity is already reached. Means the difference for a high-rise building when it comes to drainage is not the velocity in the stack pipe of the water itself, because it won't be higher. The challenge in a drainage system in high-rise buildings is that a lot of fixtures are connected to the stack. So we have to handle a higher wastewater flow, but not at a faster speed. So, and I had many discussions where there's actually a fear of water getting very fast in a high-rise building, and therefore people are afraid of the drainage. But physically there's a terminal velocity. So if it's 10 stories or if it's 80 stories, the velocity is not changing. It's that we are connecting more bathrooms, we have a higher wastewater load.
So there has been a policy about, you know, this pressure brakes or the change of directions. People are always told, you know, the taller the building, you need to break the pressure. You need to have a, you know, change of directions. Is that just a misnomer?
Yeah.
Based on your thoughts.
I'm completely deviating from the first question, but the topic I'm passionate about. So the, you know, when we have a change of direction from vertical to horizontal, what happens is we have an annular flow in the vertical pipe and we have a layered flow in the horizontal pipe. Annular means we have an air column in the middle and then the water flowing around. And in the horizontal pipe, a layered flow means we have water at the bottom and air at the top. So very simple, what happens in that change of direction from vertical to horizontal is we change from a layered flow to an annular flow. And that, when you use normal bends, causes a lot of turbulence. So we create overpressure there. But how that overpressure comes, that's also, it doesn't come because suddenly like water is pushing back, but the air, which is traveling together with the water, wants to continue to travel, but it is blocked because of a water plug in this change of direction. Therefore, it cannot travel anymore. So it's like on a highway, if you have, for example, 4 lines, then a construction site comes, and suddenly you go down from 4 lines to only 1. Then you have a traffic jam. So the same can happen in a drainage system if you change from vertical to horizontal, and that is creating this overpressure. So you can either use a pressure relief line to compensate that, or the solution we have is that you use a hydraulically optimized vent. You can see that later, or I can explain it later at our booth, where you avoid that this water plug is created.
How many safely average 3 fixture toilet can you connect to a 110 stack approximately?
The 110 stack, you can easily go to 60, 70, 80 stories. Yeah.
Even if it's double loaded, if there's two bathrooms?
Depends, of course, then in detail how many toilets, how many wash basins, and so on. But we have realized buildings where we went to, I think, 50 stories with a back-to-back or even 3 toilets. So you have, the maximum load is 576 design units to be exact. So as long as that can be covered, you can go with that.
Okay, folks, the floor is open for anybody who want to ask questions. Just call out to me, I'll get a mic. We'll continue this discussion. We can stay for as long as you are not feeling hungry. There's nice the drinks and snacks and food after this, but we can continue for as long as you all want. I think we have another 15-20 minutes. Suraj will continue with the next line of questions.
One important point over here, Suraj, just to connect. A lot of misconceptions there on vent pipes. So when you do a vent pipe stack system, I'm giving you the number 80 meters in a conventional design. The moment you go beyond 80 meters, we have this problem in our offices. All draftsmen are taught 80 mm diameter is vent stack. Inconsequential, we have that block and we put 80 mm dia and we go home. The moment your building is going more than 80 meters, the vent pipe size has to increase. Because your gas chambers will then, your pipe size will reduce. If it is kept only 80 meter, the air will not go to sway out. So beyond 80, as per fixture unit calculations, you have to enlarge the size of the dia of the pipe. A wastewater pipe has got a lot of infinite drainage. You can connect as many floors you want. But the vent stack, it might happen that you have a soil stack 100, a waste stack 100, and also a vent stack 100. So I think a lot of mistake happens. If that doesn't go well, you have got a problem of smell nuisance and also accumulation of methane. And you will not believe, why do you provide sprinklers in toilets beyond 5.5 square meters? Because as per NFPA, if you don't do that, and there is a methane accumulation and people go and tend to smoke, you can have an outblast over there. So the relationship of safety also goes to the fact of 5.5 square meters from NFPA, providing sprinkler becomes mandatory. And who would know better than Prem Saab, when their guest room toilets become bigger, they'll end up providing sprinklers inside the toilet, which holds good for most of the commercial buildings required, as well as for hotel buildings, just for the sake of relationship of safety, methane gas, vent pipe, the whole thing is one umbrella.
That's quite a good takeaway for all of us here in correlating the context of it. Question to Prem Saab. I mean, in terms of the entire building industry, the hotel industry consumes the maximum amount of water. I mean, we say from 180 LPCD to say 320 LPCD. How do you see that from a hospitality perspective? How do you take those measures to do the conservation, whether it's active or whether it's passive? Your take on that, sir?
So honestly, the perception is changing drastically, even from the guest point of view, rather than the hotel builder, the guest, the end user also, perception is changing. People are becoming more aware of water usage. IHCL for Taj, in spite of going for 4 fixture toilet in city hotels, you're going with 3 fixtures. And that has become a standard practice. Even the shower heads flow is reducing. We give bathtub only in resort properties and not in city hotels at all.
Do you have a metric of measurement per room consumption per day, 400 liters? Of course, category wise it will vary. But do you have like a target that you would want to achieve? Say, for instance, in a 3 fixture.
So we still go with
in a city hotel.
We still go with 320.
320.
320. But we have done away with as a strict measure, we've done away with the bathtubs in city hotels. So that has helped a lot. And there are other initiatives as well, like most of the hotel industry do that.
But are you consuming, reusing all the water that you all are treating, or you have to still let go of some water?
We use all the water. All the water.
I would like to add over here. So from our lot of projects done on the residential scale, Highrise is obviously very high FSI projects. And the STP water, which is the reused water which is available, is much higher in quantity as compared to the required recirculation required for flushing, for landscaping. So there is often a disposal issue of excess treated wastewater, which is there in most of the high-rise projects. What we've tried to integrate is, like, we've seen that many a times there is a mixed use component available. So recently we completed one big project again, the trees, which is in Vikhroli, premium project for Godrej Properties. So since we were involved right from day one on the infrastructure master planning issues, right till the last phase was delivered across 12 layers. So on day one, we decided that there could be a lot of reuse available in the commercial component of the building. So accordingly, a purple pipe system was laid during the infrastructure works were going on, that any excess treated wastewater available from the phases of residential will be directly taken to the commercial building, and secondary treatment will happen over there, and then we will reuse for cooling. So this was successfully adopted, but obviously the mixed use nature, the Taj has also come up over there. Partly water also goes to the Taj from there. And most of the high-rise projects do not have a mixed use component, so there is an issue, and as we all know, MOEF doesn't allow because they don't believe in the developer doing it successfully well, so they don't allow it to discharge it into the stormwater. So these are some of the challenges which we've been facing in high-rise projects. Similarly, the circular economy, which we are aware now is shaping up well. So again, diverting a little bit from the topic from water to waste. So most of the organic waste which is generated in high quantity in terms of either biogas or manure can be successfully put to reuse in such commercial mixed use. Like for example, a food court may have only biogas based burners which may actually successfully use the biogas which is generated within a methanation plant inside a mixed use campus. So these are some of the observations which we've done.
In fact, we have many of our hotels where this biogas is used for the cooking purpose in the cafeteria.
Question to you, Sandeepji. What are the changes the world is going through in terms of standardization of consumption of water across, and do you think that those standards are going to come to India in future, or is already been available and is getting implemented? What do you think about your take on that?
Actually, we are doing quite well, I would say, in terms of standard improvisation. The major problem what I feel is that unlike many other Western world where a lot of things are enforced, we go more by the society adopting it. The reason of these conferences is education more to do with. We don't charge for conferences to come over. You go to a conference in US, the minimalistic they will charge you is $200 for a 45-minute lecture. So I think more of this is education. Now coming to standard, US came out with what we know as EPACT 92, Energy Policy Act 1992, and in the EPACT they included even water saving fixtures as a part of their mandate requirement. So they said, Mr. User, you'll have to buy a tap which will give you so many gallons per liter. So if you go to US, you look at the Solace, the Solca, the overall water system, they all has got liters per minute written on it. Just do a little bit more close watch and you can find it. That helped them to reduce their energy demand because water, when being more smartly planned with water efficient fixtures, saves energy hugely, saves water, energy with respect to heating water, treating water, distributing water, recycled wastewater, all that energy cut, it comes down. That all happens. In the country over here in India, 2016 NDC, we put in the water saving fixtures. I am a little concerned and a little hurt that today most of our households would have LED lamps, including our washrooms, which are hardly used for typically half an hour, 45 minutes in a day. Average. But you and I are conscious about putting a LED lamp in our toilets, despite the usability is very less. How many of us are actually moving towards to ask for a water efficient fixture in our washrooms? We only know the gauge system of 2 types of buttons. But how much does your tap give is what we don't know. And in a high-rise building, because of the pressure being in a gradient of, I'll give you the number, 1.2 kg to 4.2 kg, we have got a 3 kg delta in the distribution system, which is anyway required for the distribution piping network. If you do not use the right water fixtures, the flow becomes dependent upon the inlet pressure to the tap. So your washroom will consume more water than my washroom, you being having higher pressure and I being on lower pressure because we are on different deltas. Unfortunately, if we can, during the audience discussion, if we can know how many of the colleagues here are using rated flow fixtures from X company, looking at its label rather than just the product. So we are still buying things by the look and feel rather than understanding. So the next move in the system will be providing QR codes on taps. You can scan, check, flow rates, pressures, graph, curve. And I think that is an education we have to still start moving. So the country is more voluntary rather than having, so if you really see, so that's 30 seconds more. In India, when we had this corona issue, US was actually having the arms and ammunition so that people don't take away my food and I feel more secure. Here, we were distributing food, keeping a little bit of mask on, to ourselves. So our country is very moral driven. So more education is required, and I think we'll then have great times ahead.
Well said. So we have Sunil Reddy sir, you have a question to ask.
Can you hear me?
Yes.
Yeah. Sandeep, the question is to you. The first thing you spoke about there is this gravity system, and then vis-a-vis you were talking about some hydropneumatic system.
Yes, sir.
Now, do we actually have a hydropneumatic now? Where is the pneumatic part in that? I don't think so.
Yeah. There's no more. No, there is a. Now the pneumatic has become very small.
That's the pulsation damper.
That's it. The pneumatic has become very small. It just makes the pump to sleep.
Basically, it's VFD.
Yeah, it's VFD. So in fact, the mistake would be to make a pneumatic bigger.
These days, everybody talks about hydropneumatic. Means there is water and there is a lot of pressure here, which is not there right now.
Sir, air is gone. Air is only to cut off the pump. In fact, the more the pump starts talking to the demand, the better the performance comes. So you need a little bit of a pressure sensor and a final cut for the pump to relax. The pump should actually work around.
Thank you,
sir.
Rakesh, I would involve you in this. It's more of a rhetoric, not a question. You see, Bombay receives huge rainfall. I was just going through some write-up. Somebody sent a WhatsApp. We receive about 1.44 billion meter cube per annum. And coincidentally, Bombay water consumption is about the same, 1.4 billion meter cube. And we still depend on these 5 lakes. And all these 5 lakes, they are on the downstream of various water, which is slightly higher than the Bombay mean sea level. So my question to you is there anything that can happen in Bombay, or some mandatory agency comes out with some provision of to harvest this huge amount of water so it does not go back to sea? I think about 95% of water goes back to sea, which is a shame. So all these 5 lakes which are receiving this water from height, they can be utilized elsewhere around surrounding Bombay. So have you heard of, or is anything in the making that things become better and we begin to use what comes from the top?
Depends on, okay, so I would like to add over here, there is one very important aspect which we did discuss during this. So we are talking about design, we are talking about principles of design, we are talking about sustainability. There is a very important element involved, which is the occupant change behavior. We have been doing a lot of due diligence for these REIT funds when they go to acquire assets. So they ask us, they have a checklist. Is there a rainwater provision for harvesting? Is the building fitted with low flow fixtures? What we've seen is that these are some of the initiatives which many commonsensical societies can take. For example, you said that 4 months there is enough rainwater available. Many of the new complexes, as we all know, BMC is just giving 90 LPCD per day per occupant. It is not giving, it is stopped giving 135 as per the code. So most of it is being coming either from the STP or from borewells. Now what we can do is, intelligently we can install a system which will directly take the roof rainwater after the first flush into the flushing tank. Then what happens is we avoid the complete usage of pumps to take the water up. So that way we can intelligently use this kind of, so this is only bringing in awareness in how we can change our behavior towards rainwater. The more that awareness is created, we will see more and more reuse of rainwater being successfully integrated in the townships.
No, awareness, yes, I think most people are aware, but nobody does it.
Correct.
There is no danda.
Yeah.
Is that danda going to be there, or it's like Chennai, they have
Yeah, wherever there is scarcity of water, then the danda comes. So यहाँ पे कोई scarcity नहीं है, कोई डर नहीं है, free में मिल रहा है पानी, as we said, so there is no value at all. So there, now in Chennai, Pondicherry, every fixture unit is being monitored now.
BMC water is not cheap, it's 100 rupees.
No, at the residential level it is cheap.
Per KL, including
That is for commercial.
For a small amount.
Yeah.
And rainwater would be probably.
I agree with you,
In terms
Sunil.
of quality, much better.
Much better.
Yeah, good evening.
Can
I have an observation. You said water is excessive, water is excessive building. I think this question is to all my architect friends here and all my consultants. I think time has come that we should rethink about using water cool systems in high-rise. We have these systems available. Unfortunately, the country didn't give them opportunity, so most of them have stopped manufacturing. But we have done 280-meter tall building here in the city of Mumbai with the water pool, and to me, this can not only take care of the problem you said that excess STP water is available, you will save also 40% plus energy for each and every occupant. Apart from that, currently the way we are all planning modular units in high-rise, we are creating a climate which is very hot for my ODUs. I have done many analysis here where the air temperatures are going into those lowered elevations which architect want to squeeze us and make it so small that vertical stack is happening. They are going beyond 50 degrees and the units are consuming more than 50 to 60% rated power, and that is also putting electrical systems into stress, causing fires. We have already seen some nasty fires in high-rise in current months. It will be unfortunate that all of us witness them. If modular units will be continued, we don't take care of this serious nature problem. I've been talking to several national forums, companies, but a lot of research needs to be done. I think CTBUH should drive this. It is a very, very serious problem, and it can also address the sustainability. Second, of course, the use of heat pump coupled with that can also be a very good sustainable solution. And the third thing, I think, high time that every liter of water which is used by any occupant has to get metered. The moment you put smart metering, I think we will resolve many issues. So I think these are three quick observations.
Agreed, Pankaj sir. So, some of the innovations which we've been trying for residential projects is the use of heat pumps. So, as we all know that heating and HVAC constitutes a major power inside each home. So, I'm talking in the sense of residential, commercial, the use of heat pumps is very well known. Last 10 years we've been doing it successfully. But residential also, what we've done is in Bangalore, in multiple high-rise buildings, we've gone for the installation of heat pumps and we've avoided the geysers inside each apartment. Now one very important flaw which comes into place because of the occupant change, behavior not being seen over there, as soon as hot water is available on the tap, overconsumption starts happening. So what we've done to restrict that overconsumption is again a smart IoT-based metering solution. So every household gets 180 liters of hot water or 150 liters depending upon the premium nature or affordability of the project, beyond which the smart meter keeps on billing them for excessive consumption. So that has brought some discipline in the hot water consumption as well. Now, an important point which I would like to leave over here is, can we take all the savings back into the infrastructure? This is somewhere which we are finding resistance. So for example, when we go to BMC and we tell them that I have used fixture units which are very efficient, ultra low flow, which is reduced the size of my STP, which is reducing the size of my piping, my drainage, please allow me to reduce the size of my storage tanks. They have a severe objection to that and they say that we will not allow that to happen. So the idea should be that we should be taking the status quo nature and challenging these beliefs, because the real savings will happen when the structural tanks are designed of lower capacity, when the loads of the buildings reduce because of the lower capacity. So that infrastructure savings has to be plowed back into the capex of the project. Then only we can say that real savings has occurred. just by doing no flow fixtures, it doesn't impact the infrastructure of the project. So this is one thought which I would like to leave the audience with, that we have to push for reduction in sizing of the infrastructure.
I have a layman observation. There was so since there's a lot of discussion on flushing, is the vacuum flushing system which I see in airlines, is that not a viable solution if water is scarce? Just a quick observation.
It's actually a good point, absolutely. So I can give you just an example from Germany, where we know some 2-3 projects where they have been using this vacuum flush system. The whole thing, why I personally think it will not happen in many projects, is today for drainage we use a gravity system. And with a vacuum system, suddenly you're bringing some mechanical devices into. Somehow you need some energy to suck that off and all of that, which also requires maintenance. So it will be a big change also in maintaining and operating the system. There are certainly also some advantages to it, that you can, for example, go without any slope, or you need smaller diameters. Or my answer has shut off the light.
We're just making it sustainable, less energy.
I think there's some signals coming in, that's all. Okay, Giriji, go.
Yeah, my question, I'm a structural engineer, so my question is related to interaction between structure and plumbing drainage. And question is addressed to Sandeep and Andreas. Okay, sorry about the 2 other gentlemen. I have to give slight background in some few sentences, and then the question is very simple. We structural engineers are asked or required to design the structures as a sustainable strategy for 3 different categories in event of a calamity, like earthquake or typhoon or something like that. So first is collapse prevention, where we design by code, and it is assumed that the building will not collapse, but there will be major damage to fixtures and other finishes and all that. The glass can break and plaster can fall off and all that. Second is immediate occupancy, where damage is limited. You can go in and start living, but all the facilities may not work. And the third is operational level, where nothing happens to the building. You can go as if there was no calamity, and everything is working. Lifts are working, plumbing is working, electricity is working, everything. Now, we take a brief from the client to what level we have to design. Now, as structural engineers, we have developed the capability of engineering our designs to 3 different categories in order that our building. So what is the use of designing such a structure if our services are not designed for that?
Tricky as always, huh?
Why should the burden be always on us?
No, it's joint, sir. We are all joint. The only thing which a services consultant always is worried about is the expansion. Because that's where we feel the building when it has its own positioning. And yes, sir.
Sorry, but in a high-rise, the most important aspect is the sway.
Absolutely.
Sway and traffic.
Yeah, so high-rise, yeah, I agree with you. The sway part of it is very, very much addressed with respect to loops and contractions. So there are provisions, even if I have been looking at buildings which we have done 275 meters, 300 meter tall. So you have got seismic controls and seismic support requirements for services installation. Many of the colleagues sitting in this room would understand that NFPA 13 gives you very, very detailed guidelines about fire protection systems, seismic control, because let's not forget those are high pressure lines. any rupture, any breakage of those pipes will have also collateral damage to the project, to the services system. So for me, more than the water supply and drainage, the fire becomes more of an A category issue. Because even if the building has had a problem and there are water services and the drainage services interruption, and as you very rightly said, the building is fit to go inside again, we cannot have a system in which the building services fire system is defunct. For a while, now in fact, if you talk about, not only plumbing we talk about rising mains. Rising main and electrical systems do have got seismic controls. You have got seismic supports requirements. So I think very clearly there are aspects of selecting the services, and as you rightly said, 1, 2, 3 category, depending upon the height of the building, the sway, and I told you expansion joint, because expansion joint is something which we have to deal with day in and day out. High-rise buildings, out of people in this room, we are doing 30%, 20% of our projects. 70% of our projects are still normal buildings. When I say normal, means 50, 60, 70 meters tall. Now those are no more high-rises as such, if you ask me. So typically speaking, Suraj, when I even work and we went around in a hotel or a hospital, which is never a high-rise, it's only 30 meters. There is also the resilience of the continue functions is highly required. Data centers, another buildings which I would say services, fire, which is again electrical, HVAC. So there is a category wherein you classify the data centers objective of its continuity of operations, and that's where the services categories are then classified based upon the use of the building. That's what it is.
Okay, yes, I can add only a little part for the drainage part. And here I can also not speak about PVC, which we manufacture. So one is the impact resistance, and especially of the joints. So for us, we are following also European norm, for example EN 1519 or even a Swiss norm, where it is defined how much also sway the connection still has to resist. So in our case, that is, for example, a test of that you have to 4 degrees to all the directions have to be sustained, and still the connection has to be tight. So that is taken care at least with HDP, what we are using. And we have never heard of any building all around the world where, for example, the connection has been breaking because of that. Yeah.
Thank you very much.
Let me answer you on that part. Since we have designed the 420-meter tower, so we have considered all those things. The building sway, the thermal movement, the wind movement, the building settlement because of its own weight, the building settlement because of its own weight. So we have considered all those things. So like fire. So in the fire system, we have everywhere used the group fittings. The group fittings also comes in 2 model, fixed and the flexible. So flexible gives certain amount of flexibility. Drainage system. So there are 2 types of drainage system. There are 2 types of connections which are coming in the drainage system. One is the solvent type, another is a push fit type. Push fit type give you certain amount of flexibility in the system, so that your system shall be available for that. Similar kind of things happen with the electrical distribution. Same kind of things have been considered in the lift, so that in the case of a defined parameter of building sway, building settlement, or thermal movement, or seismic, these things can be taken care. But if the seismic characteristic is beyond your defined characteristic, then it will be complicated.
So I have a question or maybe an observation, Girish. You asked a question to Sandeep and Sandeep answered it. Who takes the owners of both the designs? If your building is designed, his system, his services are designed, who coordinates the both the things? So from the question when you asked him and he answered, I as a client, I'm worried now that who's taking the responsibility of both the designs? Who's coordinating?
No, that is why I asked the question, because every discipline, see, I cannot design plumbing systems or drainage systems, right? So I take care of structure. So even if my structure sways to, let's say, 600 millimeters in an extreme earthquake or cyclone, my structure will still not collapse. It will not undergo any damage. But at the same time, these services systems must be resilient enough to undergo that deformation. So that onus is definitely with somebody else.
No, I got that, but both are interrelated.
Yes.
Like, we design the facade, various factors are taken into consideration
Right.
and so on and so forth. So there has to be a mechanism where, probably Sandeep would have never asked you your design parameters.
There you go. As I said, tall building is a highly interdisciplinary design process. And Sandeep should tell me or Andreas should tell me that their systems can undergo only so much deformation. I have to take that into account. On the other hand, if I say that with all these parameters, my building is going to sway or it will have an inter-story drift of, let's say, 30 millimeters, they should come back and say, so this is a coordination between all of us. And it's not only them, it's lift, it's facade, everybody. So unless we have a proper dialogue amongst all of us together, tall building design cannot be done.
Sir, I wish we could have shown you, sir, a project which we did together, 90-meter high swimming pool between two buildings.
Yes.
And we had to work together to understand how the services and the structure will talk to each other. Mr. David said, I'll give a structure to you which will expect this much of sway. And we selected expansion bellows to consider that sway which he was wanting to consider in his design parameters.
Yeah, that's more still more of a structural thing, but when you are taking vertical services on a high-rise, that
everything we got from him.
I don't know what the
I guess there is still a need of yet another.
No, it is the answer
I'll tell you the coordination efforts which went into that project. Forget plumbing, drainage, which was maybe simpler for you there. But there was a swimming pool. There is a swimming pool, which is a ready-made swimming pool, some stainless steel, and they were product. So that swimming pool is infinity pool. So while the buildings can sway here and there, the infinity effect should not go. And water should not spill out.
Yeah.
Which means it's like a gyroscope. The swimming pool has to be like a gyroscope. It has to remain level. Now this requirement was told to the swimming pool people, and there is a mechanism there which will actually bring into effect that aspect. So that coordination has to be there. So that gyroscope fellow had to incorporate our sway, and we had to tell them what was the sway. So every discipline has to talk to other disciplines.
The most important is structure.
Girish, sir, we need to. Girish, sir, we need to wind up. One last question.
Yeah, structure discussion is already.
Never ends.
Never ends. Sorry.
It's the last question to you, sir. We would request after that a key takeaway from all the panelists.
Thank you very much. My question is to Mr. Bhatia. He just mentioned about the climate risk, assessing the climate risk and accordingly suggesting the mitigation measures. So, considering the Mumbai generally we have the climate risk is mainly about sea level rise, and another thing which now since last I think 4-5 years we have been experiencing about the cyclone which we had never experienced. So how if it is a small plot, not even a small plot, let's say it's a 1 acre of land, and he wants to construct a building, a high-rise building with 3 or 4 levels of basement within it. So how the climate risk is assessed, and whether it has been, apart from these two, whether there is another third elements of the climate risk there, and is it been done anywhere? I'm an environmental consultant, so my
yes. So I will give you some guidance now. There is a matrix available which is called the BRI index, which is a building resilience index. This has been brought forward by World Bank, which is IFC, and especially for coastal cities where the climate risk phenomenon is much higher, they've created a systematic process of evaluating that risk, and then there are mitigation measures suggested. So this is not only on the flooding side or the change in climate side, but there are other risks, other factors which Girish sir spoke about. So all that is systematically produced as a framework which you can use for any property. So if required, we can circulate that link also, which will give you the entire parameters of the risk coverage.
I think we So we wind up. You can ask them. You can meet them in the meet.
I think the counters are all getting open, and we thank you all.
Counters are already open. One huge round of applause for the panelists. They taken their time and given out very insightful information.
Thank you to you both also.
Thank you so much.
Thank you very much. Thank you everybody for being here till the end.
A big round of applause to all the audience. Also, you have participated quite well. Thank you, sirs. Thank you for all the time, and I would request you to stay back. We have some mementos for you.
Here is some.
Okay, so people are not leaving me, they want me to come on dais all the time, but to hand over the mementos, I call upon Suhas Deshpande, please come over and felicitate Sandeep Goel here. Please come on the stage and hand over the moment to Prem Kumar. Nikhil Sanghvi. Subodh Arora, please come over. Mr. Rakesh Bhatia. Matthews, can you help me? Andrea, put your hand. Mukesh Jetli, please come. Acknowledge Rohit Mukhil's contribution. Mr. Narkani, can I call you please? Suraj will be happy to get memento from your hand. Thank you everyone, and I announce the session officially closed. Please join us for cocktails and dinner in the next hall. Thank you and good night.